And welcome, everyone. We should be live. Well, actually, not live because this is a pre-recorded session, but welcome, everyone. I'm David Tischler. I am a developer advocate at Balena, and I'm joined by, wrong way.
Kyle Harding. I'm a Balena OS developer at Balena.
Awesome. Thanks for joining us today, Kyle. I'm really excited to hear about the project that you've built. We're going to talk about PiHole, which is well, you know what? I should probably have you describe it. Give me just a quick 1-minute overview of what is PiHole before we go into the deeper dive on it.
Yeah, like Balena aside, PiHole itself is a community-driven ad blocker project. It operates in the DNS namespace, so that's your domain name server. So essentially, your phone book for the internet. If your browser or any other service wants to reach a website via its domain name, like google.com, it needs a phone book to convert that into an IP address, IPv4 or IPv6 address. What PiHole does, it sits in the middle as a local phone book that can choose to reject certain domains. So if it looks at a domain and decides this seems to me like an ad site or a tracking site or anything else that you've decided to block for any reason because it's completely controllable, it can return a fake address for that, and thus nothing gets loaded, you don't see ads, you don't get tracked. Anything that appears to be valid or isn't blocked just gets handed upstream to either your ISP DNS servers or Google DNS servers or Cloudflare, or even if you want to use the built-in unbound recursive DNS server, it'll hand it off to the next person with the real directory listing. PiHole just sits in the middle and blocks what you've configured it to determine to be bad.
Oh, that's awesome. I mean, ad blocking aside, the privacy aspect and implications there are super cool. So the PiHole application, as you mentioned, is a community-driven project. In this particular case, what you've done is taken it and containerized it so that it's able to be deployed directly onto Balena devices. And we'll get into that in just a moment. You mentioned, though, that it's community-driven. So is that safe to assume, then, that it's an open-source project that's available in GitHub?
Yes, it's fully open source. Okay. They have an entire org at github.com/PiHole because there's a number of components. It used to be one big repository, but they've broken it out into FTL, which is their fork of DNSMask, and their admin UI. It's 4 or 5 components now that make up the PiHole when you install it on your desktop or your Pi, and their Docker image, because they do maintain a Docker image. So all those repos are available at separate repositories under the PiHole org itself. It is fully open source, and I believe all of the developers that work on it do it for free or for tips or donations. Is the only income these people make, as far as I know.
My goodness. All right. Well, that's pretty awesome. I do see it's github.com/pi-hole. I'm going to put that up on screen real quick for folks. Now, you have taken that project one step further. There's the upstream GitHub repo right there. And you have taken the project and, like I said, containerized it. You did mention they have Docker files available. You've gotten it to run on a Balena device. Now that gets interesting then, because as we've got Hackathon attendees watching today, a lot of them had mentioned in their survey sign-up, a registration sign-up, that they were new to Balena and getting started with containers, getting started with Docker. So this is interesting then, in that your repo is ready to go. It's fully built. Hackathon attendees can just simply deploy the thing and away they go. And then they've got ad blocking on their network, and they've got some privacy filters and controls in place as well. But because yours is also open source and available on GitHub, they can learn from and sort of reverse engineer and understand a bit about what you're doing then, as far as the creation of the Docker file, what that looks like. We'll pull up your repo in a moment. is it safe to assume you have a Docker Compose file in there as well?
Yes. In the root of the project is a compose file, and there's only a couple services running, or 3 services, and there's a Docker file for each PiHole and Unbound, and the host name block we're actually pulling from upstream.
Perfect. So let me do this. Let me get my screen share up and running then. I'll bring mine in first. We'll take a look at your screen share in just a few minutes. But I want to then show off. So here's your GitHub repo. And sort of like I was saying then, this is a great way to learn what's going on. Let's add that in. Now here's your GitHub repo. I'm already on the Docker Compose. The Docker Compose file, like you said, consists of a series of services. So obviously the first one here is PiHole. You can see that being brought in. Unbound, you mentioned earlier. Unbound, remind me what role that container is playing.
Unbound, it's difficult to fully explain how it works because I'm a bit confused on it myself. But what it is it's a self-hosted recursive DNS server. So DNS servers usually live in the cloud, operating as these giant phone books of the entire internet. By default, usually your ISP provides you a DNS server. A lot of people who don't want to go through their ISP might point to Google DNS or Cloudflare DNS. So you might have seen people using 1.1.1.1 for Cloudflare or 8.8.8.8 for Google DNS. And that is just pointing to a different cloud-hosted phone book. The problem with these, there's obviously a lot of them out there. It's not just those are just the 2 big ones, is they often track the queries you're making. Your ISP or Google could be recording not what exactly it is you're sending to these websites, but it knows you've been to this website because you asked for the address. So if you're asking Google, hey, what's the address of balena.io, it'll give you an IP address, but Google also now knows that your household wants to go to balena.io. So there's a tracking aspect. So for the extra paranoid who don't want to use a publicly maintained DNS provider, there are options that keep no logs or promise to keep no logs, and you can take them at their word for that or not. Or you can run a service like Unbound, which is its own self-hosted recursive DNS. It does very nearly the same thing that those big cloud providers do, but you can run it on your network, and it actually operates at a much lower level, asking each layer of the domain where to find these pieces. So there's no one server that knows what URL you're going to, because it's going to talk to the .com, and it's going to talk to the next level and the next level to build out the entire URL. It's much harder to track. It's much less likely to be keeping logs of your activity anywhere. That is running in the stack as an option, but by default, I've configured it to use Cloudflare because it's just the most popular option. If you want it to be more paranoid, though, there's instructions in the README on how to point your server to Unbound instead.
Yep, I see it there, the 1.1.1.1. The last bits of the puzzle here are the FBCP, which is what frame buffer. That's what renders the dashboard. We'll get to that in just a moment. And you're doing, what is this host name? You are bringing in, sets a host name, I see it right here, of PiHole on the device. So that's what would show up on your local network. Let's also take just one quick glance. Like I mentioned, a lot of the attendees today are just getting started. So let's have a look at a Docker file. And here's your Docker file that launches the application. We're not going to go through it line by line, but it's enough to just sort of glance at that you're pulling from upstream the PiHole Docker. That's their, what is the word I'm looking for? Their registry location, right?
Their official Docker Hub images.
Yeah, Docker Hub image, right. And the version is there as well. I can see you're bringing in, let's see here. You
can probably skip those 2 lines. Those are being moved and reworked anyway at the moment.
Okay. Curling in PiHole here, setting environment variables. So you can see how environment variables are set, and then some dbus. Is there not a launch script? I'm
No, we're using the default one. So because we're using the official upstream image, we
aha.
aren't changing the entry point or the command in this particular case. We do some custom steps, but because the PiHole upstream image is actually using S6 init as its init system, it allows you to, instead of changing the entry point or the command, it allows you to drop a script in a custom location in the image, and that script will run on boot up. So you can see copy cont init.d. That
Yep.
is the line, and the services line below it are copying my minor customizations into the image so that it can do things that are a bit more unique to the balena stack. So not all images will have this. A lot of images don't have an init system at all, but this
Yeah.
particular one does. S6 is a very minimal init system that is popular for containers.
Gotcha. Yep. So here's the inits right here. I got it now. I was expecting to see a launch script further down at the bottom with a CMD or a run, but you've got it all here in services. So that's excellent. So let's take a look then at this project in action. Like I said, folks can go and have a look at this as a fully functional project. This is a great template to learn from, but I want to see this thing in action. So Kyle, if I take my screen share off and I add yours, what does this thing actually look like? Let's do this.
We can look at the web dashboard here, yeah.
Add you in, and I've got your screen share loaded. And so this is, yes, the local IP address. So you have deployed this onto a Raspberry Pi locally. We're going to talk about deployment in one more minute, but I want to see this thing and what it does. So you've got a local IP address there. You are logged in or not quite yet?
Not yet. I can quickly log in here.
No, that's all right. And so here we go. So do you want to give us just a quick guided tour? What am I looking at here?
Sure. This is the PiHole native database. No matter how you install it, whether you use balena or not, this is what their web dashboard looks like, where you can manage your device. It doesn't need to be done by a command line. They have a nice CLI, but you don't need to use that. This is where you can see the kind of activity on your network. So the idea would be that you'd point all of the clients on your network or your router itself to the PiHole for DNS lookups, and then you can see the domains being looked up, whether they're allowed. There would be another blocked domains list over here, so which domains are being blocked the most. It gives you percentages of how many are blocked and how many are on your block list. You can manage your block lists by going into, I think it's under lists, domains, add lists, and you can add, see, this is the default list of domains to block. You can add new lists there. They're all, a lot of people publicly maintain them in the PiHole host format, so you can add new lists of things to block. You can customize your own list of what to block to allow. You can also block individual domains rather than just having a whole list there. And the query log will show you like queries as they come in from devices on your network. It shows them being logged and whether they're blocked or not. And very conveniently, if you see something load on a website that you don't like, and then you check your query list, you can immediately blacklist that website or whitelist if it's been blocked. It's very fast, especially when, why isn't this thing working? You can go look at the recent queries and realize that it's been blocked or it's been allowed, and you can change that with one click from here. So this dashboard is where you can do all the managing of things on your network. But out of the box, it's already doing its job. You don't need to load this site unless you're curious or troubleshooting why behavior's not doing what you expect.
Well, that's the beauty of, like you said, it's a community built project. People have put in a lot of work, a lot of time. They've already got a lot here. You can, of course, like you said, add to it, but it's a fully functional project ready to go straight out of the box. Well, that's really neat. Boy, I could have a lot of fun. I could really mess with my wife. But so then let's talk about deployment. Let's do this. I'm going to bring your screen share back out. I'm going to put mine back in because there's a couple of different ways to deploy this. And knowing that folks are quite a few of them are beginners. Let's show the easy way to do this. Let me bring mine back in. And over here in Balena Hub is sort of like an app store for IoT devices. Essentially, these are projects that are ready-made. And you can see right here, we've got an entry here for PiHole that can be deployed onto devices. When you click on Get Started here, you'll get a pop-up for choosing the type of device. I see that it's defaulted here to a Raspberry Pi 3, but I also noticed, let me get this out of the way, that it works on a Pi 2. You've even got the Nano Pi Neo Air listed, as well as the Balena Fin, which is cool, and I see a couple more as well. If anyone out there happens to test it on another device, by all means, PRs are welcome. Let us know and we can get it added. But when you click Get Started, you can download your Balena OS image, flash it to an SD card, power on the Pi or other type of device. It will take a few minutes to download its containers after it has booted. Again, you've already built those containers. The workload is already defined. It just needs to be brought down to the device. Kyle, do you remember off the top of your head, is it about a gig worth of containers? Do you know? Is it less than that?
I would think less than that. The biggest one is PiHole because I don't maintain it and I can't make it smaller.
Sure.
I think it's less than a gig. I would say closer to 800 megs.
You know,
We could look at the releases tab, but
that's all. That's all right. The point being is that certainly give it some time. Depends on the speed of your connection, the speed of your device, and the speed of your SD card as well. But all said and done, at the end of the process, you will have the Pi running. It'll be on your network, and it'll be available at either, look up the IP address in your router lease, or did I see that it would be available at http://PiHole? Was that the host name? Or
yeah, it'll be at PiHole.local with no hyphen. If your this is interesting though, that if your DNS is already pointing to that device, so if you have figured out the IP address and changed your router settings to use the PiHole as your DNS, or maybe even just your client, it will actually also resolve pi.hole/local will resolve to the device, which is a good way to know that your DNS is working properly. If you can hit pi.hole/admin and it loads your dashboard, then you know that it's actually using the PiHole itself for DNS. Both methods work. The host name here, PiHole.local, is going to work whether or not your DNS has been remapped. It's just an MDNS lookup.
Great, awesome. So then at that point, your Pi is configured. Everything is working out of the box. Your blacklist is all in place. And your dashboard should be up and running. Now, that is the easy way. Of course, you can also do it the more difficult way, but still easy. And you can use the Balena CLI tooling. If you've got the Balena CLI already installed, it depends on which order you're watching these videos in, but if your CLI is already installed, you can do a git clone on this repo, then change directory into that local folder on your machine, and do a Balena push application name that you create or define from inside of Balena Cloud. So in Balena Cloud, go create a fleet, give your fleet a name, download your SD card image, flash the SD card, power on the device. The device will join up to that fleet, but not have its workload yet. The Balena push fleet name will send the containers, the build essentially, up to the cloud. Balena Cloud builders will churn through those recipes, build the containers, and send them down to the device. And we have documentation for that. We're going to have sessions actually devoted to that. So check the schedule. If you need some help, we'll be walking around. We're certainly available as well to assist. But the point being, you can clone the repo, send it up to the cloud builders, and they will churn through the build and drop it onto the device for you. So
we've also got the button on this page if we're guiding people to the button.
All I had to do was scroll.
There you go.
That's almost too easy. Or option 3, click this blue button. And it will trigger the build for you as well, also in the cloud. So lots of options. The documentation that you've got here is amazing. We also have this blog post that will walk you through the whole thing as well. So you've got everything you need to get started between GitHub, Balena Hub, and the blog post. Let me pull this blog post up real quickly. There is the URL for it. You can, I mean, it's kind of long, so obviously you can just do a quick Google search and it's the first entry in Google. And it'll walk you through essentially everything that we discussed here on this tutorial video. Anything else, Kyle, that I've forgotten? I think we've covered it all.
The blog post, I think, still references this. It's a bit out of date, but there is the optional screen attachment for this project. So if you have a TFT display attached to your screen, you get the possibility of a mini dashboard that shows directly on the device itself. It's different than the web dashboard. I don't recall if this blog post still references that, but it's something the README, there it is. There's a picture right there. So that is included. That's what the pad thing is that we're adding to the Docker image. So if you have a screen attached and you familiarize yourself with the FBCP module, you get a little quick heads up display, and you don't even need to go to the web page to get some basic information about what's happening. That's
super cool. That LCD right there looks like one of those 3.5-inch ones that sits on top of the Pi. I might even have one on the desk. Do I have? Nope, not on my desk. Go figure. The one time I don't have it. But yeah, that one looks like one of the ones that goes straight onto the GPIO headers, although I know the 7-inch Raspberry Pi official goes from the flat ribbon cable. So you may have to do a little bit of research. Oh yeah, I can see this is the link to the Pi TFT display.
Yep.
But either way, that's really cool because now you've got a device that you can stick on the desk and, you know, monitor at all times. Yeah, neat.
Yeah, that's entirely optional too. You can run this project without the screen. It shouldn't change the behavior at all. It's just a nice little bonus if you happen to have one lying around.
Yeah, absolutely. All right. Well, thank you, Kyle. I definitely appreciate you taking the time. If anyone has any questions, by all means, just simply reach out. You know, it's GitHub. You can obviously open up issues. Certainly PRs always welcome if there's anything, any features you want to add or see enabled, or have in fact tested on other devices. And other than that, I think we're good. Let's pull this screen share off.
Thanks very much, David.
Wave goodbye, and thanks again. Appreciate it, Kyle.